Numbers are one of the oldest ways to encrypt information. Question. Realistically today, why is it important to be able to encrypt information? What kind of information? Classified. Okay, so there are different agencies, government agencies usually, but also even private contractors that have classified information that people shouldn't get. Okay. It's like actually like military assets, et cetera, et cetera. What beyond military? Let's make it even more practical. Aiden. Social security numbers, yeah. How much is done online these days? Basically, right? Not just like keeping track of your own information, but even payments that are made online, et cetera, et cetera, et cetera. Like everything's done online. How many of your parents that you know of, as far as their purchases, like their debits, their credits, what they pay, what they deposit, do they still keep track of in their checkbook ledgers? 1, 2, 3. You don't know. Like whenever they're at the store and they use their debit card, are they actually writing it down somewhere? Some people do, but the majority of people just say, I'll check my online statement. I'll check it online. I'll do my online banking. But what's the struggle as soon as you say, I'm doing everything online? It can get stolen if it's not enciphered well. Have you guys ever seen something like well, maybe you guys haven't done it a lot yet. But there is a lot of, this is encrypted with this and this and this sort of encryption. Encrypted, what are they doing? They're basically trying to hide your information so that someone can't steal it. Why is it big news when a hacker gets into some sort of bank's information? Or some sort of online platform's information? Yeah, because they just stole all that stuff and they have access and they can use it in ways that are detrimental to you and beneficial for them. Kyle. I don't know about Expedia. I didn't think it was that. At some point, like, there were some banks that people were afraid of because they said that there was like a lapse in their security or someone had gotten through their system. I don't remember any other. I mean, they're always like the big ones like Facebook, et cetera, that there's been major issues as far as, but they were actually selling information. That was different. Oh, yeah. It's all about the privacy agreements that no one ever reads and just says, agree, sure, whatever you say, I trust you. Anyway, coming back. We're not going to go too deep in this. I just want to show you an idea of how using matrices and coding messages can get way harder. In the early stages, how could you use numbers to encrypt information or to hide information? Well, the easiest way is to do something like, right? Just something super basic. Let's just say you wanted to encrypt danger, yeah? If you were just to do a where each letter of the number, right? You could go ahead and say, okay, I have 4, and then I have 1, and then I have 14, and I have 7, and then I have 5, and then I have 18. You could go ahead and just give a list of numbers. That's a random list of numbers. What on earth? Now, what if you put all those numbers in one big old long line? Do you guys see one way that could get complicated? Is it 4 or is it 41? Is it 1 or is it 11? Is it okay? So something to separate. get to 26, and then you could start over at the beginning. So there's one AB, even that could way through until you're done, and then you would go to the and then you just have it repeating through numbers. Okay, you could then shift that. You could then reverse. That could work. Just kind of simple. Always, always that message that message. E goes with this number, or this number goes with E, and so it's to some degree still fairly easy to break as far as a by hand encoding. What do matrices do? Well, they change the whole game. Matrices. They change the whole game. Let me go ahead and show you some examples, and then we'll try to, as a class, figure out how they change the game. What if the message is meet me Monday? Okay? This is the uncoded, sorry. This is the message. The first thing that you're supposed to do is write uncoded row matrices. Now guys, careful. Some of this vocab is going to be completely new to you. So if you need to do a certain directive, if you need to do a certain operation direction, you need to have the vocab. So if I were you in a different color even maybe, I would give the directions because these are the new vocab. Here's your message. Just as an example, meet me Monday. Uncoded row matrices. Uncoded means, okay, just keep it basic. So therefore, we're not going to do any crazy shift ciphers because don't worry, matrices are going to make it hard enough in a second. We can just keep it basic as far as A is 1, B is 2, C is 3. Now, they went ahead, they don't even, if you guys notice, they're making little matrices so the spaces denote different letters. But then they're also putting in zeros to actually be the spaces between the words. Okay? Where did all these numbers just come from? Up on the board, right? So who is M? M's 13. Who's E? It's 5. Who's E? It's 5. And then who's... Wait. Why did they just... What did they tell me to do? Yeah, 1 by 3, aka I'm going by 3. So I'm making one big old line and I'm going by 3. So I'm taking this message, I'm cutting it down into 3s. I could have cut it down into 2s, I could have cut it into 4s or to 5s or to 6s. I have to somehow cut it down. If for any reason you ever get to like the end of your message and you need to finish off your row matrix, you would just add however many zeros you need. So the uncoded row matrices are merely take the letters and put them into numbers. Okay? Pause. That is uncoded row. I think I need to grade notes a little bit more closely if you guys are just staring at me the whole time. Uncoded row matrices. You write this because every year kids get confused, and it's not a hard process, but you have to know the vocab. Take the message, put it into numbers, split that message into 3s. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. I add a 0 at the end. Once you have your uncoded row matrices, now you need to encode them. Now the book would say take each row matrix and multiply it. That's super annoying. If you had to put each of these into your calculator and multiply it, because I'm letting you use your calculator on this, so annoying. So what instead would you do? I would tell you to go ahead and make however many sets of 3 you have, which in this one it's 1, 2, 3, 4, 5. Go ahead and make a 5 by 3. And just do it all at once. It's so much easier. So go ahead and put in your 13, 5, 5. Go ahead and put in your 20, 0, 13. Go ahead and put in your 5, 0, 13. Go ahead and put in your 15, 14, 4. We need one more line. Let's see if I can get a little more room. Bless you. Go ahead and put in your 1, 25, 0. Make your 5 by 3. And all we need is an encoder. Back in the olden days, get Cracker Jacks, you'd have like an encoding ring. You could decipher like a hidden message. This whole thingamabob. An encoder, basically you're just taking a message. And ironically, this is not encoded yet. It just was a strict letters to numbers relationship. But now we want to mix it up. Now we want to make it more complicated. Now we want to hide the message beyond just the simple, oh, hey, this letter is this number. How does matrix multiplication make it so much more complicated? This needed to be an invertible matrix, which means you have to always multiply by some sort of square matrix. Has to be legal. Whatever you set your message into determines the size of your encoder matrix. And invertible, the determinant can't be 0. If you were to ever encode a message with a matrix whose determinant is 0, it has no inverse. So great, you just got it all mixed up and you can't possibly ever get back. Well, that's a bummer. Give that one to a friend and be like, how do we get to it? Okay, go team. So if you were trying to hide it, you always need to hide it with, encode it with some sort of, it can be any 3 by 3 whose determinant is not 0. Guys, I want you to look at the original message. You can look at the original message. Now look at it. Do you see how there were repeated 5s? And there were repeated 0s? The repeated 5s were E's, very commonly used letter, and the repeated 0s were blanks in between words. Where are the 5s and the 0s now? Wait a minute. Those aren't even the same number anymore. But they're both E's. Yeah, but as soon as we multiply by a matrix, remember you multiply, 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 add? It took all of our numbers and it gave us a completely different set of numbers. Some of them are negatives, some of them are positives. It all comes back if you're able to undo this process to be numbers that attach to letters. But right now, if you're looking at these numbers, I don't see any repeats. I don't see any spaces. All I see is this random collection of numbers. What determined how big, how small? Well, the numbers that you put in here. So you could have even made that messier, put in fractions, etc., and that would have gotten so much worse. You see kind of just a slight little peek at the benefit? So what originally had repeats, had like different placements of going to, now is all changed. This is an E and that's an E, but you can't tell because of all of our matrix multiplication. Gavin, go ahead.
So the one on the bottom right, that's the two matrices above it.
Multiplied together, yeah. So technically, if you think about it, this was my graphing calculator. Because my graphing calculator, you have to make one matrix together. So I made the first one, my message, A, and I made the B, and so I multiplied it. Now, how do we undo multiplication of a matrix? If I wanted to decipher? The uncoded matrix is this guy right there. Matrix is that guy. The coded matrix is that guy right there. How would someone, if they had your coded matrix and if they knew what your encoder was, how could they possibly get back? Inverse. So how do you decode a message? Multiply by the inverse. So to finish off this problem, if you wanted to make sure that everything was proper and that the person should be able to decipher it, if they had the encoder and they had the coded matrix, they would just have to do the coded matrix times A inverse. Hey, doesn't your calculator have an A inverse operation or an A inverse ability? Cool. In order to get the original 13, 5, 5, 20, 0, 13. And then they would be able to take that decoded message, which is what we would call this guy, and they would go back to A is 1, B is 2, C is 3, and figure out what your message is. Now, what could you do? If you had your own message, your unique message, first of all, you would have to choose, am I going to split it up by 3s, by 4s, by 2s? It all determines, or it all depends on what encoder you're going to use. Are you going to use a 2x2, a 3x3, a 4x4, a 5x5? But you would take a message, you would figure out what your encoder is, what size you want to make it. You would split up your message based on those increments. You would go ahead and make a whole matrix message after taking letters into numbers. Make sure your encoder actually doesn't have a determinant of 0, or else remember, there would be no way back. And then that multiplication, that set of numbers, boom, there you go. So, with that, I want you guys to go ahead and encode for me. Help is on the way. Ready, set, go. Encode. Get it in code. Get it into a coded message. Calculator all the way, all the way, all the way. I think I said yesterday at the very beginning of this section, calculator for everything except maybe Kramer's rule. Because the Kramer's rule you can kind of do by hand quickly, but everything else, calculator all the way. P.S. Did I already make this kind of easy on you in that I already made you the uncoded messages? How did I get my 8, 5, 12, 16, 0, 9, 19, 0, 15, 14? How did I get all those? Yeah, good. Letters to numbers. Could you encode piece by piece by piece by piece by piece by multiplying, 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 multiplying? Yes. Or you could make this what size matrix? 9 by 2. Okay, too many hints, too many hints. I want you guys to try to encode it, and then once you have it encoded, check with the calculators, check with the people in your group. Do you guys know that people used to be called calculators, the ones who would do all kinds of calculations? Interesting. Before the machine, calculators were people. Yep. Great movie. What did I just say? Is it a 9 by 2? I think so. Yeah. P.S. As soon as there are a lot of numbers, it is so easy to make mistakes. Just be careful in inputting. Ooh, we need to be careful in inputting numbers. Anybody ever heard of the career of being an accountant? Just saying. Or a data analyst? Or a lab technician? Ooh, precision. It's key. If you multiply the wrong way, your calculator will let you know. Once you have it, compare. Make sure that data got put in correctly, et cetera, et cetera. Compare with people in your group. Make sure everyone's on the same page. And then if your group agrees with the encoded matrix, then I want you guys to try to decode it and get back to the original message. Yeah, totally cool. I'm going to freeze the screen so you guys can't see what I'm doing. See if you have the same encoded, and if you do have the same encoded, as soon as your group agrees, pause, make sure they agree, show each other what you got before you write it down. And if it agrees, then try to decode it. And it should come back to the very beginning.
I checked with White and we got the same thing, but my matrix it's not like showing the scroll.
Oh, yeah, you have to scroll. Does it not scroll?
It only shows 6 or 5. It doesn't go down.
Oh. If that happens, go do it again. And then see right away, right? And then you can scroll down while it's still on it.
Oh, so you have to do it when it's still
Yeah.
on it. Okay.
Yeah. There you go. If any of your other guys, Gavin just brought up a really good point. If you don't start scrolling right away, not like right away as in like a time frame, but when you first hit enter to get the result, if you start to do something else, or if you like go down, or if you, I don't know, if you do operation, you can't go back to the same matrix and scroll the same way it lets you scroll the first time in some of the older calculators like this. So just go back and do the multiplication again. You'll see little arrows and you can scroll up or down in the matrix. Does that make sense, kind of? So if you can't scroll up and down to see everybody, go do the multiplication again. Just scroll up and get the exact same A times B or whatever you have, and then do enter. Okay. Or actually, let me just unfreeze the screen, I should say. You guys read off what you get for your encoded. Keep going. Keep going. Uh-huh. Uh-huh. Not negative 99? Okay, got it. Negative. Got it. Uh-huh. Uh-huh. You guys agree? Now, would you necessarily give someone that as your encoded message? Because right away, as soon as you give that to them, what could anyone know as far as your encoder size? Your encoder size has to be a 2x2. So what would make it even more hidden? You just wrote these in one long line. Why? Well, could have been a 2x2, 3x3, 4x4, 5x5. Who knows? Who knows what matrix was used? Does that make sense? So this isn't how they would give you an encoded message. They would probably give you like, ooh, all of these have been put into matrices. More like a long old list of numbers. Probably separated by commas just to give you some sort of point of reference. However, I didn't just ask you to encode. I asked if you could go back, because why give a coded message that can't be? So therefore, how did you guys indeed? First of all, if you were to give this to someone, you wouldn't give them this matrix. You just gave away exactly what size your encoder was. Not that they know exactly what was in there, but there are only so many options of what could be in these spots. Well, I don't know about that. But how do you decode? Did it work? Well, I guess for most of us, we probably made that one A and this one B, right? So then I would say multiplied by B inverse. If you guys made this one A and this one B. And you should be able to take the very same matrix that you guys just got. Do you guys get times to see if it worked? And then you could have used second matrix, and then B is my other one. Both a little inverse button, right? Go. 8, 5, 12, 16, 0, 9, 19, 0, 15, 14, 0, 20, 8, 5. I got my matrix back. Did it work? Worked for me. Double check in your groups real quick. Make sure everybody can do it. And as soon as you guys have it, here's what I want you to do. I want everyone in your group to go ahead and turn in the back of your homework spiral. No one speaking. I want you to encode a message that is at most 15 letters long. Keep it appropriate. Turn in the back of your homework spiral. I want you to set up an encoded message. Back of your homework spirals in your workspace, back of your homework spirals in your workspace. You have to come up with a message. You're going to have an uncoded matrix. You're going to have to choose an encoder. You can choose any size, a 2x2, a 3x3, a 4x4, etc. Then, once you have your message ready, whether you have 4 people in your group, 3 people in your group, 2 people in your group, somehow you're going to have to make sure everybody, so don't just switch with one person or else one person is going to get left out. But go ahead and give to one person in your group your encoded message, but don't give it to them in a matrix size. Give it to them in a long list of numbers, and then give them your encoder. Give them, well, they have to have the encoder or else they won't be able to decode it. But they'll have to figure out what size the encoder is and how to use it appropriately, and then how to get back to the message, how to translate it to letters. So in the back of your homework spiral, this is your workspace. I want you to think of a message around 15 letters long, maybe a little bit shorter, maybe a little bit longer. Could have multiple words. Keep it appropriate. You choose what size encoder you want to use, a 2x2, a 3x3, a 4x4. Get the encoded message and then write it out as a string of numbers on someone's notes in your group. Remember, if you're group of 3, you can't just go like you get theirs, they get yours. You're going to have to like you give them and they give it to the other person gives it to you. But think of a message. Get the uncoded matrix. Figure out an encoder matrix. Give them the encoded separated by commas, not like in a nice matrix, because that already gives it away as to what they're supposed to do. Give them the encoded message in their notes separated by commas along with your encoder matrix, and then they have to figure out what your message says. You guys got it?
Yes.
Make up one of these. Put it into numbers. Figure out the size encoder. Like you literally make up a matrix. Wait, I can make up anything? A 2x3, 3x3, a 4x4? Maybe don't go too big because your message isn't very long. But what's the one thing you have to be careful of when making up an encoder? Okay. So you go from here, figure out what size you want, 2x2, 3x3, cut that guy up into whatever you need, encode the message, give them the message separated by commas in their notes with the encoder matrix and say, encode my message. Only give them this separated by commas, all the numbers, and then this. They need that separated by commas and that. In their notes, that will be their last example for today to decode that message. But you guys can be setting it up, getting it ready in the back of your homework spiral. And then when you're ready, be like, hey, give me your notes, and you can write it down and say, the message. Go. Is that cool? Careful, don't be doing it in your notes, or else when they go to put their problem in your notes, they're going to see what the answer was. That's lame. Yeah.
How do you want the uncoded to be? Whatever we want.
Separated by commas. Oh, mean the message? Anything you want that's appropriate, that's around 15-ish letters, maybe a little bit less, maybe a little bit more. It depends on what you choose as your encoder. Does that make sense? If it's a 2x2, split it up in 2s. If it's a 3x3, split it up in 3s. But you guys get to make up whatever matrix you want. Just make sure his determinant's not 0. So while you guys have been working on your message, I encoded my own message. So if I was giving it to my person, I would put this whole long list of numbers. I didn't show them a matrix at all. I just showed them the message. That's been encoded. I have to give them an encoder and say, go, decipher, decode my message. Yeah. It has to be a square matrix. It's not 0. Remember with your encoder, whatever you choose, it has to be a square matrix, a 2x2, a 3x3, a 4x4. And whatever you make, a 2x2, a 3x3, a 4x4, is what you split your message up into. Yeah, that one, separated by commas. And then you have to give him your encoder. Once you have one ready, ask for someone's notes and be like, I'm ready. Here's my number, commas. If you need help, ask. Your group's waiting. Once it's encoded, ask someone for their notes and be like, here's my message. Try to decode. You have it ready, Jaden? Do you have a message? Is that your message? And then you multiplied by that, and you got that. And his determinant's not 0, right? Double check real quick. Because if it's 0, they won't be able to go backwards. So do determinant. Is he in the B spot right now? Okay, you're good. Whew, that was close. So now you just need either Lacey's notes or Tony's notes, and you're just going to give him these numbers separated by comma. Does that make sense? Jaden's ready to give someone a problem. It doesn't have to be in your homework spiral. Give her your notes. Who's going? Okay. So then, Tony, you're giving Lacey your problem, and then Lacey, you're giving your problem to Jaden. So Jaden, give him that last one, separated by commas, and then give him your encoder, the little 2x2. Anybody else need help? I'm ready. I took my message. I made it into numbers. I figured out who my encoder was, and that's what I split this guy up into. Mine, though, if you look at it, I would have split my message up into 3s because I chose a 3x3. And so then I made a big old matrix from my message. I multiplied it by the encoder. I got this, and I wrote this just separated with commas. Does that make sense? So this is after multiplying the message by the encoder, separating with commas and saying, here you go, figure out my message, given this encoder one. Did you already figure it out? Has anybody deciphered one from their group yet? Get in there.
So which one do you
You have to undo the encoder, yeah. And you split this guy up into 2s, right? Because he's using a 2x2?
Yeah.
Good. Does anybody use a 3x3 like me? Oh, a 4x4. Nice. Yeah. You can't, because what's your message? This one? 1, 2, 3, 4, 5. Yeah, that's okay. As long as you're multiplying by a square matrix, your encoder is square, you're good. This can be any size. It can be super long or super short. It just has to be by 3s. Oh, the encoder has to be a 3x3. Yeah, because it has to have determinant, not 0, which means... Just you guys are changing. So tell Angie. You can borrow her note. You did it? Yeah, the inverse of the encoder. In order to decipher, you have to use the encoder. If you guys want, you can take a picture of mine and see if you can decipher mine. You're not going to have enough time to do it in class, though. Take a picture of mine on the way out and see if you can get my message. What? If worst comes to worst. If worst comes to worst, take a picture and try to decipher mine. If worst comes to worst, take a picture of mine and try to decipher mine. Oh. You have to do message times inverse. So is that the encoder? Is that the little baby guy? Then switch it. Do J, which is your message, times I. Because remember matrix multiplication? Because this isn't the identity. So you can't just go either direction. Ooh, that looks like maybe letters. Take a picture of mine. Try to decipher my message. I'll see you guys later. Robbie's putting on his shades. Bye, guys. Did anybody decipher a message? You will tomorrow? Okay. Keep trying to figure out what the message was from your group member. Mine's encouraging. Try mine.
Jesus loves you.
Nope. But that would have been encouraging, too. For some.
Why is a bot?
Whoa.
That's mine.
Did you give out your message? It's like giving out his password. What's going on?
Yeah, that's already my will. Like, it's so complicated.
Encipher the entire thing.
So in order to get to my will, we're gonna have to decipher. In order to decipher, they're gonna have to go through like a little